Hello, boys and girls. We're on Chapter 10, Lesson 6, Find and Draw Lines of Symmetry. This is kind of a fun chapter and a fun lesson, isn't it? Okay, so the directions here for number 1 and number 2. Now, number 1 they already did for you, but I had to put it in here because of the directions. It says, tell whether the shape appears to have 0 lines, 1 line, or more than 1 line of symmetry. So for the answers, we have to write 0, 1, or more than 1. Okay, so for example, here on number 1, this figure of the letter T has 1 line of symmetry. Now let's look at number 2. Number 2 is like a checkerboard, right? Like you're playing checkers. It's too small for checkers though. Okay, so we're looking at lines of symmetry, which is the line you can draw where you can fold it and it's a perfect match, or where there is an exact mirror image of the other side. First, I'm going to try a vertical line. Oh yeah, if I folded it right there, it would be a perfect match, right? So that's at least 1. Horizontal, absolutely, right? Can you visualize folding that? Yeah, now look at this, guys. How about corner to corner? Yeah, that's another one. And so it's a square, so another corner to corner. So that had a lot of lines of symmetry. More than 1. Hooray for this lesson, right? Let's keep going. It says, does the design have line symmetry? Now, line symmetry is just whether a shape has a line of symmetry that makes it symmetrical. Does it have line symmetry? Later, you're going to learn about rotational symmetry. So they call it line symmetry now just for you to get used to it. It's just where if you can draw a line of symmetry, it has line symmetry. So we just have to write for this one yes or no. Well, that's pleasant. If your answer, oh, but there's more here, look. If your answer is yes, draw all lines of symmetry. Oh, okay. Well, they added a little twist at the end. All right, let's look at number 5. It's a square. All right, we already did this with the checkerboard a lot, didn't we, guys? So it has a vertical line of symmetry, a horizontal line of symmetry, and corner to corner, corner to corner. So we write, yes, it does have line symmetry. And then we drew all the lines of symmetry. We drew 1, 2, 3, 4. A square has 4 lines of symmetry. Let's take a look at number 6 now. Okay, take a look here. I like to look at vertical lines and horizontal lines first, and then think diagonal. So I think a vertical, yeah, I think that is a line of symmetry, because that is a mirror image on either side of that line. And how about a horizontal line of symmetry right on that vertex, right? Those 2 vertices. Yeah, totally line of symmetry. So you get a yes. Now, did we draw all the lines? When I look at the diagonal, right, I'm just trying to visualize that. If I folded it on that line, no, that would not work. So I think we drew all the lines for 6. All right, let's look at number 7 now. Ooh, number 7, some sort of a, well, I guess it's a J, right? Like a squared off J. Okay, let's see. Does it have line symmetry? So I always think vertical and horizontal. Ooh, it doesn't have either one of those, does it? Because of that little guy right there. And then this part up here is higher. Yeah, I don't think it has, it definitely doesn't have diagonal. Yeah, 7, you get a no. You have no lines of symmetry, so you have no line symmetry. All right, let's keep going. This is down at the bottom of the page, problem solving. It says use the chart right here for 12 and 13. Okay, which number or numbers appear to have only one? Okay, so only one line of symmetry, exactly one. So let's look at each of these. A 0. Now you kind of have to look at how these are drawn too, because you can draw numbers in lots of different ways. So 0, whoopsie, those weren't very good. I'm gonna try them again. Yeah, well, just pretend I did those really nicely. 0, the way it's drawn there, definitely has 2 lines of symmetry. So it doesn't have only one, it has more than one. The number 2 right here. I don't think it has any lines of symmetry, does it? Yeah, because of that little loopy guy. All right, let's move on to 3. Definitely not a vertical line. Ooh, but what about a horizontal line, boys and girls? If we folded the 3 on that line, those two sides would perfectly match up. And there's no diagonal lines, so 3 has exactly or only one line of symmetry. So let's check the others. 4, no, that doesn't have any lines of symmetry, does it, guys? I'm visualizing all the different ways you could fold it. Nope. How about 5? No. Right? No, because it has like 4 and 5 have all these little special doodads, and that has that diagonal right there. All right, 6. Yeah, I don't think so because of this little guy right there. None. All right, let's look at 8. Ooh, no, wait a minute. Yep, I think 8. So let's try vertical. What do you think, guys? Yeah, I think 8 definitely is a vertical. Let's try a horizontal line of symmetry. Oh, yeah. How about diagonal? Diagonal? No, that's like a rectangle. You know how you always think a rectangle has a diagonal line of symmetry, but then you fold it and it's all crazy looking? This does not either. So this just has the 2 lines of symmetry. So that does not have only one, so we can't count 8. And then 9 is just like 6 flipped around, right? So 9 doesn't have any lines of symmetry. So the only answer for 12 is the number 3, because it's the only one that has only one. Okay, so 13, which number or numbers appear to have 2 lines of symmetry? Oh, well, they're the only ones that had other lines of symmetry, right? 0 and 8, right? 0 and 8. All right, you guys are doing awesome. Okie dokes, we're on the back now, the lesson check. It says, how many lines of symmetry does this shape appear to have? Now, they always say appear to have because they don't have the measurements on it and stuff like that, but how many does it have? Okay. All right, this is a hexagon, right? And it looks like it's a regular hexagon, doesn't it? When a shape is called regular, that means that all the sides and angles are congruent. Okay, congruent means same shape and size. So this is a regular hexagon. All the sides appear to be equal and all the angles appear to be equal. Okay, so I always like to start with vertical. I don't know why. Yep, 1, 2. Let's try a diagonal. Oh, yeah. 3. And then the other, I'm like tipping my head as I'm doing this. 4. Okay. Okay, so look guys, if we went from a vertex to a vertex on this line, we can do the same thing on these two vertices. That's the 5th and the 6th. Ooh, looks like a spider or something, doesn't it? So this has 6 lines of symmetry. Okay, so do you know, I may have told you this, my trick for remembering hexagon, right? Sometimes I confuse hexagon and pentagon because pentagon's like so random. There's no little trick to remember pentagon. Hexagon, I remember, it has 6 sides because you don't use the letter X very much, right? So hexagon and 6 both have the letter X in them. And that's how I remember hexagon has 6 sides. Okay, and then the other thing, if you have a regular polygon, meaning all the sides and angles are congruent or equal, however many sides the shape has, that's how many lines of symmetry it's going to have. That's a little fun fact. Tell your teacher you know that. Hey, regular polygons all have the same number of lines of symmetry as sides. Your teacher will be like, Johnny, you're a genius. All right, let's keep going. This is our lesson check. Now, we're still in the same chapter on this lesson check, but that's okay. It's this chapter, lesson 4, just a couple days ago. Kevin draws a figure that has 4 sides. All sides have the same length. Well, you know what I'm thinking right now. 4 sides, all sides have the same length. I'm like, square. Okay, let's keep reading though. His figure has no right angles. Oh. What figure does Kevin draw? Well, could it be a square, you guys? Let me draw a square and check it. A square, of course, as we know, has 4 right angles. So, what is the other figure that has 4 sides that are all the same length? It's not a square. It's not a trapezoid, because you know a trapezoid, or, right, only one set of parallel sides. Trapezoid. And it has, well, no, not the right. Okay, so a rhombus. Oh, yeah. Think about, oh, this is what I was going to say about a trapezoid. All the sides aren't equal. A rhombus. Okay, these are the little hash marks to show those are all equal sides. I always call a rhombus a sat upon square, like someone sat on a square and crushed it. 4 equal sides, no right angles. He drew a rhombus, right? Because then let's look at rectangle. Rectangle also has 4 right angles, right, guys? Okie dokie, artichoke. You did excellent.